Welcome to Basic Chemistry Workshop. Today we shall be discussing acid-base titrations. To understand the concept of titration and calculation of the strength of acid and base. Titration terminology. Titrant, the known solution which is added from a burette. Analyte, the unknown solution. Indicator is used to signal the end of the reaction or end point. Acid-base titration. An acid-base titration is an experimental procedure used to determine the unknown concentration of an acid or base by precisely neutralizing it with an acid or base of known concentration. This lets us quantitatively analyze the concentration of the unknown solution. Principle. A solution called titrant is added to the sample to be analyzed. The titrant contains a known concentration of a chemical which reacts with the substance to be determined. Due to the chemical reaction taking place in the sample to be analyzed, the characteristics of the sample changes. This change of the characteristics can be detected by an indicator. A color indicator changes its color as soon as all the substance contained in the sample has reacted with the titrant added. Applications. Titration is used in laboratory medicine to determine unknown concentration of chemicals of interest in blood and urine. Specific titration procedures exist to test free fatty acid content, unsaturated fatty acids, and trace amounts of water in food industries. Titration is used in the production of biodiesel to determine the acidity of waste vegetable oil, one of the primary ingredients in biodiesel production. Titration is used to test the underwater environment in freshwater and marine aquariums. Properties such as water pH, concentration of ammonia, nitrates, and nitrites are measured. Normality. Normality is defined as the number of gram equivalent present in 1 liter solution. It can be written mathematically as gram equivalence of solute divided by volume of solution in liter, or weight divided by equivalent weight into 1000 by volume in ml, where equivalent weight can be calculated as molar mass divided by small n, where small n is the number of H plus ions in acid, OH minus ions in base, N for salt, charge present in ionic forms. Units of normality are capital N or equivalent per liter. Aim: to find the normality of given HCl solution. Apparatus: 25 ml burette, 10 ml pipette, 50 ml conical flask, beaker, funnel, burette stand. Chemicals used: 0.1 normal NaOH solution, HCl solution of unknown concentration, phenolphthalein indicator 1%. Procedure: fill the burette with prepared 0.1 normal NaOH solution. Remove air bubble and adjust solution to lower meniscus on the burette. Pipette out exactly 10 ml of HCl solution and transfer it to the conical flask. In the same solution, add 2 drops of 1% phenolphthalein indicator. Titrate the solution against NaOH from burette with constant shaking till the solution in the conical flask turns from colorless to pink color. This is at the end point of the titration procedure. Repeat the procedure more than 3 times and calculate the normality of the HCl solution. Let us see how the experiment can be conducted in a laboratory. We have taken 0.1 normal NaOH solution, unknown concentration of HCl solution and 1% phenolphthalein indicator. We have taken all the required glassware and set up the experimental glassware as shown in the video. Once the experimental setup is ready with us, we shall start taking 10 ml of HCl solution. Pipette out carefully 10 ml of HCl solution and transfer this 10 ml of HCl solution into a conical flask. After transferring 10 ml of HCl solution into the conical flask, fill the burette with already prepared 0.1 normal NaOH solution. Remove any air bubbles inside the burette and adjust the solution in the burette to lower meniscus. Then add 1 to 2 drops of phenolphthalein indicator to the conical flask. Now simply open the valve of the burette and see that solution from the burette falls into the conical flask drop by drop. Care should be taken to properly agitate the mixture in the conical flask. For the same thing, in this video we have used a magnetic stirrer which continuously agitates the solution present in the conical flask. Continue with the titration as shown in the video till the solution in the conical flask turns from colorless to pink color, which indicates the end point of the titration. As we can see in the video, the solution in the conical flask is changing its color from colorless to pink color, showing the end point of the titration procedure. Once we see this color change from colorless to pink color, carefully note down the reading from the burette, which tells you the end point of the titration. Repeat this titration procedure more than 3 times and go for the calculations. Observations of the study. After the end of the experiment, tabulate the observations of the experiment in a table as shown. The first column of the table shows volume of the HCl solution in ml. The second column shows volume of NaOH solution, that is burette reading in ml. And the third column shows the mean burette reading in ml. Total NaOH solution taken in burette 25 ml. HCl taken in pipette 10 ml. Endpoint is colorless to pink color. Calculations. Normality of NaOH solution taken is 0.1 normal. Normality of HCl solution is unknown. Volume of HCl pipetted out is 10 ml. Volume of NaOH solution, that is mean burette reading, is 10.2 ml. Calculations. N1V1 is equal to N2V2, where N1V1 terms stand for NaOH and N2V2 terms stand for HCl. 0.1 into 10.2 is equal to N2 into 10. So that the normality of HCl N2 can be calculated as 0.102 normal. Thus, the normality of the HCl solution is 0.102 normal. Lab assignment. If 25 ml of citric acid solution is titrated with 28.12 ml of 0.1718 normal KOH, what is the concentration of citric acid? If 31.87 ml of base is required in the standardization of 0.4258 gram of KHP having equivalent weight 204.23, what is the normality of the base? Calculate the normality of NaOH solution formed by dissolving 0.2 gram NaOH to make 250 ml solution. References: Experimental Physical Chemistry by V.D. Athavale, P. Mathur, New Age International Private Limited. College Practical Chemistry by V.K. Ahluwalia, S. Dhingra, University Press. Thank you.